Okay, this is MAT 175, lesson 38, section 9.4. We're working with vectors, properties and principles of vectors. To start with, we have two vectors that we are adding together, vector v and vector w. Now think of it this way: vector v has got a horizontal component of 1, 2, 3, 4 blocks horizontally, and vertical movement of 1 block up. Whereas vector w has 1, 2, 3 horizontal component 3 and 1, 2, 3 up. So between the two vectors, they move 1, 2, 3, 4, 5, 6, 7 vectors across or horizontally, and 1, 2, 3, 4 vectors up for a sum vector of v plus w, where that resultant, or what's known as the resultant vector, the black one, starts where the initial point for v starts and ends or terminates where vector w terminates. When we're adding vectors, can be commutative. Follow the commutative property where vector v plus w can also produce the same result as if we started with w plus v. So in other words, if we started with vector w down here and then did v cross, you get the same resultant vector as if we did v first and then w. Vector addition is also associative, where in parentheses we would add v plus w first and then add vector u, or you can add u plus vector v first and then vector w, and again you get the same result either way. Here we have vector v plus 0 equals to 0 plus vector v, and so basically nothing's changed. Here we have vector v where we're going 1, 2, 3, 4 units to the right or horizontally, and 1, 2, 3 units up. So you can see that the arrow moves where we have a terminal point, and then an initial point and then a terminal point moving to the right and up. Here the initial point is to the right and up, and the terminal point is down and to the left. So here we've gone 1, 2, 3 down, and 1, 2, 3, 4 to the left. So this would be a negative vector v. And so if we were to take the two vectors, add them together, positive v plus a negative vector v, you can see that the two vectors cancel out. And when we get into the next lesson, we'll see where this plays into effect in trying to solve our vectors problems. A scalar is where we have a number times our vector, such as 0 times a vector v is going to be 0. So we get a 0 vector, nothing happens at all, it just goes to 0. 1 times vector v, that's just vector v. And then negative 1, we get, in other words, that when we multiply negative 1 into our vector, the vector changes direction. Here we have alpha plus beta, parentheses times vector v, so it's like we're distributing this v, vector v, and then alpha, and then vector v times beta. And saying here, vector alpha gets distributed into vector v plus vector w. Here we have two numbers multiplied together times vector v is those two numbers, the product of those two numbers times vector v. Alright, let's take a look at some graphing vectors. Here we have vector v, and it's got 1, 2, 3 units horizontal component and 1, 2 units vertical component. Vector w has, the original vector w has 1, 2 vectors down, and then 2 vectors to the right. So when we want to apply v minus w, then what happens is the w switches direction to make it a minus w. So instead of starting up here and terminal point down here, now the initial point becomes down at this point, and the terminal point is up here. So that would make it go 1, 2, 3, 2 spaces to the left, and 2 spaces up. And that's what happens here. See, here it shows the terminal point, the initial point, the terminal point, and now here there's the initial point and the terminal point. So the minus w switches direction. Same, still 2, but now it's still going to be 2 units instead of 2 units down and to the right. It's 2 units to the left and up. And that's what this is, 2 units to the left and up. To give you minus w. So here's your vector v, 1, 2, 3 up to the right, 2 up, and the vector w is 1, 2 to the left, 2 up. And so the initial point for v minus w vector, your resultant vector, is the initial point for vector v, and the terminal point for your resultant vector is going to be the terminal point for your last vector, which is minus w. Okay, here we have 2v plus 3w. So since v was 1, 2, 3 places to the right, now it's going to be 2 times that. 2 times 3, now it's going to be 6 places horizontally. And instead of 2 spaces up, it'll be 2 times that. It'll be 4 spaces up. So 6 spaces horizontally and 4 spaces vertically. And that's what we get here. Now, for w, it's in the same direction as what we had before, but now it's going to be 3 times that. So it's going to be, instead of 1, 2 spaces down, it's going to be 3 times 2, or 6 spaces down. So it'll be 1, 2, 3, 4, 5, 6. And then instead of being 2 spaces to the right, it's going to be 6 spaces to the right. So it'll be 1, 2, 3, 4, 5, 6. And so your resultant vector, again, it starts at the initial point on one vector and ends at the terminal point of the other vector. And then for C, here's your initial vector again, vector v. Now it's going to be 2 times that minus w. So that one, the second vector is going to be switching direction. So that'll be, instead of being 2 down and 2 right, it'll be 2 left and 2 up. And see, there it is. Here's your 2v, and then here's your 2 left, 2 up for vector minus w. And then vector u, that's just 1 space to the right, which is here, and 3 spaces up. And then again, the initial point starts at the initial point for your first vector, and the terminal point, your resultant vector, is at the terminal point for your last vector. Find a position vector. Okay, now here we want to find your horizontal and vertical components of your vector. In other words, the horizontal displacement and the vertical displacement, or the difference in spaces horizontally and then difference in spaces vertically. And notice these are angular brackets here, not curved. So this is the symbology for a component form of our vector. And so this is very important here that we have to take x2 minus x1 and y2 minus y1. So in other words, the initial point here, that would be our x1, y1. And then the terminal point, that would be our x2, y2. If you do it any other way than that, then what's going to happen is your vector is going to have the wrong direction. So you have to make sure you get that right. And see, here's your x2. This would be x2. Here's your x2, y2. Here's your x1, y1. So this is going to be x2 minus x1, and that's your horizontal displacement. And then y2 minus y1, that's your vertical displacement. And so that gives you your direction and in both the x and the y displacements. So if we were to look at this, and let's say here we have, you got P1 is -1, 2, and P2 is 4, 6. So this will be your x1, y1, and x2, y2. Now how do I know this is x1, y1? Because this is point 1 and this is point 2. So our vector is going to be x2 minus x1, and then y2 minus y1. So this will be x2 is 4 minus a -1, and then the y2, that'll be 6 minus 2. And so we end up with, of course, that'll be 5, comma, 4. So we have a horizontal displacement of 5 units, or 5 units to the right and 4 units up. Alright, and so if we were to look at this, if we were to start from the origin, this would be 0 to 5, so that would be 5 spaces to the right, 4 spaces up, and there's your vector. But here, we didn't start at 0, we started, because we started at -1, 2, and went, and then we had to subtract, figure out our horizontal vertical components. We still ended up with 5, 4, but it's not so easy to determine as if the point initiated at the origin. Okay, and so so we have our component form, but we also want to look at it in terms of I and j. I would be the same as your horizontal displacement, and that would be the same as your x values. J, that would go along your y axis, or your vertical displacement. So if we were to look at this in terms of, if you had 1, 0, and for your first vector, and so your second vector is 0, 1, then we can say that this would be 1i and 1j. If vector I is 1, 0, and vector j is 0, 1. What we could do here is add these two together. So basically what I like to do is work them vertically. Vector I, that's 1, 0, and vector j, that's 0, 1. So vectors I plus j would be 1 plus 0, that's 1, and 0 plus 1, that's 1. So we can see that we have this, our component form of our vector, and our vector in terms of I and j. So we could say that this is vector v is 1i plus 1j. Okay. Adding and subtracting vectors algebraically. Now, here we have vector v. Now we use a for like a number, like 2i plus j and so on. So in other words, let's say we had here a vector 2, -3. Okay, and this is our vector v. Okay, so this is a component form. So our vector in terms of I and j would be 2i minus 3j. So the 2, that's always, our horizontal. the first one, that's always our horizontal. So the A here, that would represent your horizontal displacement. B, that would represent your vertical displacement. So that's where the AI plus BJ comes in. So the 2 in this case, that would be the A, and minus 3, that would be the J. So if we wanted to add these two vectors, basically we add the two I's together with the I's and the J's together with the J's. And now they tend to work these horizontally, but I like to work them vertically. I think it works out much better and it's easier. And now here, if we have alpha times vector v, then that would be alpha times a plus alpha times b. So in other words, if we had, let's say, 2 times vector v, let's say vector v here is 2, 3. And now let's say we want 2v. Okay, so the 2, that would be the alpha. And so basically all you're doing is you're taking 2 times 2 comma negative 3. And so that would come out to be 2 times 2, right? And so that would be 4. And then 2 times a negative 3. And so we end up with 4 comma negative 6. Okay, and so that's all about. And that's what this is here. This double line here with the vector, that's magnitude. And basically that gives the how elongated the line is. And basically this is nothing more than the Pythagorean theorem, where we have your horizontal displacement plus squared plus vertical displacement squared, and we apply the square root to that, and that's magnitude. So with this, see here, this would be A units, and then here's B units, and here's our vector v. So basically, this is, if we were to look at this in terms of the Pythagorean theorem, this would be like saying v squared equals to a squared plus b squared, or a1 squared and b1 squared. And then we just apply the square root to that. Well, magnitude is always positive, so we drop the plus or minus, and so that's where we get our magnitude is equal to the square root of a1 squared plus b1 squared. And that's our magnitude, or like our strength of our line, or our elongation of our line, if you will, or our distance from the initial point to the terminal point. And that's all we're going to do for this lesson for right now.